So for p, we have 0 to pi over 2, and then the integral of cosine theta divided by cosine theta plus sine theta. Okay, now remember, we have to make sure na hindi nagsi-zero yung ating denominator. Okay, so for this, we set this equal to 0, and ano ba yung value nung theta natin na magpapa-0 dito sa ating expression. Now, this is only true when you're at the fourth and second quadrant. Kasi, if you try to draw your Cartesian coordinate plane, we know very well na if this is your angle, okay, so alam natin na yung cosine value mo dito is negative and the sine value is positive. And of course, this is 3 pi over 4 kasi this is yun nga yung angle doon. So basically, since negative positive, then you'll be able to get a zero value for this, as well as taking in consideration yung negative value dito, or as we cross the pi region here, this becomes a positive value for, negative value for sine, and then a positive value for cosine. So with this, magiging 0 din yung ating solution. So in this case, the restriction or our function should be bounded to those values, no? Dapat hindi sila mag-meet doon or discontinuous sila doon sa ganong values. Pero either way, kung hindi naman ganon yung values, so they must be existing. So with this, theta must not be equal to 3 pi over 4, and then of course kung tatawid ka pa ng isang pi, so you just have to add pi dun sa 3 pi over 4, so this becomes 7 pi over 4. So most probably yun yung two values natin in the from 0 to 2 pi region. So if you try checking that, you can actually try checking that, no? If you try to substitute your cosine 3 pi over 4 and then sine 3 pi over 4, tas pag pinag-add mo is 0, so hindi yun pwede yung value na yun, as well as yung 7 pi over 4, and then should be getting a 0 value for that. Now, how about your value pi over 4 at saka yung accompaniment niya dun sa third quadrant? So hindi siya hindi siya restriction, kasi alam naman natin na if both of them are positive or negative, then they will just add in magnitude, and then okay lang naman kasi the restriction is just this value should not be equal to 0. Now let us check kung from 0 to pi over 2, mamimit ba natin itong 3 pi over 4. So basically, since this is more than pi over 2, then we can integrate this kasi wala tayong discontinuity from this domain or these limits of integration. So therefore, we can integrate this expression. Now, let's do integration now. So, if you try substituting this expression in terms of letting u equal to sine theta, kasi may cosine dito. How about this cosine theta? So, wala tayo dyang magagawa. Kasi, ayun na yun eh. Nandiyan na siya. Hindi na natin siya masosolve. Kasi, alangan namang lagyan mo ulit siya ng du dito. So, that's impossible. How about if you try to make this the conjugate? So pag ginawa mo siyang conjugate, that is cosine squared theta minus sine squared theta. And ano ba yung magiging niya? Ano ba yung magiging ano ba yung magiging property niya? So yung property na pwede nating apply doon is our cosine to theta. And if it is at the denominator, so that becomes secant to theta. Matitira sa'yo dito is somewhat cosine theta minus sine theta. So that makes the equation more complicated. Kasi remember our property before, we just use your sine and cosine, and then hindi tayo gumagamit ng secant double angle dun sa ating properties where we can provide a certain directly integrable procedure kasi iba talaga siya sa secant. So with this, I'll be doing the one in the handout wherein I will substitute this, yung ating integrand, in the sense na gagawin ko yung cosine of a minus theta. So that is cosine of pi over 2 minus theta. So, di ba, tandaan niyo yung limits. You can add the limits and then saka mo isubtract ngayon yung function. So, pwede natin siyang gawin ngayon just to make this simpler. So, ba't ko gagawin yun? So, kasi it will make this a lot simpler dahil yung ating limits is pi over 2 and then 0. So, this is cosine and sine. So, you can just expect na pwede tayong mag-cancel out ng mga values dito. Okay? And of course, kung redefining at redefining lang, hindi kasi posible yung ating letting u at saka yung ating conjugate dito. So, we'll try to use another rule in this. And this is a very special case in this one. So, let's try expanding this. So, we have 0 to pi over 2, and then this is cosine difference of two angles. So, that is cosine pi over 2, cosine theta, and then since this is negative, so that becomes positive cosine, sine, sorry. So, that is sine pi over 2, and then sine theta. Okay? And then the theta, and then we have here, so this is the same expression as the above. So cosine pi over 2 cosine theta plus sine pi over 2 sine theta, and then the last one is a difference of two angles for sine, so that becomes plus sine sine theta cosine sine pi over 2 and then cosine theta, and then minus cosine pi over 2 sine theta. So hopefully you still remember your some difference of cosine and sine rules sa trigon, no? Tandaan lang yung pag cosine, cos, cosine, sin lang yun. Tapos opposite, dito sine. Pagka naman sine, sin, cos, cosine. Then same sign dito for the middle operation. Now, let's try simplifying this, no? Kasi we can simplify a lot of terms here. Now remember, if we have cosine pi over 2, that is 0. So this becomes 0. Now this sine pi over 2 is 1. Okay, so this leaves out our sine theta. Now, how about this cosine pi over 2? Same lang pala to. So, 0, and then this one is 1. Okay, and then this one is sine pi over 2 cosine theta. So, this is 1. Okay, and then finally, this cosine pi over 2 is 0. Okay, so with this, we can say na our expression is sine theta over something like sine theta plus cosine theta d theta. Therefore, this expression is actually equal to this expression. So we can say that this is equal to the original expression. Okay? So this is our expression. Now, what if we try to add these two expressions? So therefore, the antiderivative would just be 1/2 of this whole expression because they are just the same. So in this case, if I try to take the half of the antiderivative of the expression of 0 pi over 2, which is sine theta plus cosine theta over sine theta plus cosine theta d theta, okay? So this should be the same as the integrand of, the same as the antiderivative of this expression. Kasi they have the same denominator. So if I try to add again, ulitin natin. For example, if you have the integral of a that is equal to integral of b, okay, and then you try to add these two, diba, that would be the integral of a plus the integral of b. And if this is equal to something like the integral of a plus the integral of b, then therefore yung ating integral of b is equal to 1/2 of the integral of a plus b. So I hope this makes sense, no? Kasi since this one is equal to the integral of a, you can just substitute this and then take 1/2 of that, and then you'll be able to get the same result. So ganun yung naging concept dyan. Parang algebra lang naman, no? So, kaya naging 1/2 na siya. So, again, this is equal to the integral of 0 to pi over 2 and then cosine theta over cosine theta plus sine theta and then d theta. So, with this, we can just cancel this out and then we can integrate this 1/2 from 0 to pi over 2 and then d theta, which gives us a very simple expression that is theta, okay, theta, and then evaluated from 0 to pi over 2. By the way, meron pa ditong 1/2. Okay, so 1/2 theta yung ating final form. So therefore, you can just integrate this from this expression, then we have 1/2 times pi over 2, which gives us the final value, which is pi over 4. And this is your final expression. Okay, so hopefully ay na-follow nyo yung nangyari dito sa case na to. It's just that we use the general expression wherein you can pwede nyong ilagay itong limits nyo before the expression inside the trigo. So ang ginawa ko is nilagay ko dito, so ito yung pi over 2, ito yon, kinuha ko siya dyan, nilagay ko siya doon, and then minus ngayon ito. So, pwede kasi siyang pi over 2 plus 0 kasi 0 to eh. You should be adding that. Pero syempre, 0 naman siya, so alam nga namang ilagay ko pa. Had this been, let's say, pi over 4, so you can do plus pi over 4 pa here. Pero, hindi siya ganun case kasi 0 naman. So, ganun din siya sa lahat. Now, for example, if this is, halimbawa, naging cosine 3 theta. So, what you'll be doing is that you have cosine of 3 times pi over 2 minus theta. So, magiging ganyan siya ngayon. Hindi siya something like pi over 2 minus 3 theta. So, hindi. Kasi kailangan naka-3 yung buong expression. So, hopefully ay nag-get siya. And then, dito sa portion na to kung saan nag-add tayo, imagine this being equal to each other. I mean, hindi imagine kasi equal talaga sila. So, if you have integral of a equal to integral of b, so therefore, kung gusto mong hanapin yung integral of b, pwede mo sabihin na that is 1/2 the integral of a plus the integral of b, because this integral of b is just the integral of a. So parang ganun yung concept niya, no? Okay, so with that simplifies our expression very easily, and then this is your final answer, pi over 4. Okay, and we can't arrive on that expression kung magre-redefine lang tayo using our previously mentioned methods like conjugate or whatever. Maybe it is possible, but it will require us a lot of identities and a lot of a lot of knowledge in, I mean, a more advanced knowledge in trigo just to make this equation equal to 1/2 theta. So I guess that's all for your P, and then the last one for this is your Q. Now for the last one, we have an absolute value function from -4 to 5, and then we have x plus 2 dx. Now it is important for us to realize in this case na for any absolute value function, there is an abrupt change somewhere at the graph, which can be equated. You can just equate this to 0, and then you will be able to find that abrupt change. So that is from -1 and then -2. So basically dito sa portion na to, nagkakaroon siya ng abrupt change. So basically, kung meron tayong, for example, your x is equal to -1. So therefore, this is just +1. Then for an x that is equal to 0, that is +2. So makes sense for this line. How about if x is equal to -2? So our x becomes 0, your y becomes 0, and then if it's something like -3, so that becomes -1, but since it's an absolute value, so that becomes +1. So basically, yung v shape na yan is to be expected on a what do you call this kind of absolute value function. Now remember, if this is the graph of an absolute value function, so that is -2, okay, and this is the graph of that function. And then if you try to find the area under this curve, that is -1, -2, -3, -4. So probably it is somewhere here. Okay, so this is that graph. Okay, and then this one is 5. So 1, 2, 3. 1, 2, 3, 4. Somewhere siguro dito. Okay, so hopefully ay ma-mirror natin ng tama. Oops. Okay, so ito yung ating magiging probably yung figure natin, no? Now imagine if you would be integrating this just for the sake from -4 to +5. Again, this one, though this is not actually a discontinuity, but we can call this as an abrupt change. Okay, so meron kasi ditong certain value na nag-0 agad tayo, and then nag-iba na siya agad. So for cases like this, parang critical point siya, no? So we have to dissect this integration in terms of two parts. So alam naman natin na if it's x plus 2, diba? This is kind of similar to having this positive x plus 2 and then this negative x plus 2. And then what is that particular equation wherein this is your x plus 2 and then this is your x plus 2? So we dissect the two equations dito. So alam naman natin na this has a positive slope. So if you try to rewrite this in terms of your expression in terms of y equals mx plus b. Okay, so this expression, kung mapapansin nyo, this one, x plus 2, has a positive slope. So again, pag positive slope, we know that this is that portion, positive slope kasi ito kasi increasing siya. So therefore, this is your x plus 2, positive. Okay? Now this one, this particular portion here, na pababa siya, we know that this is the negative side of that. So that is negative x minus 2. And this is that particular equation. So therefore, if we rewrite this integral expression with an absolute value, we can actually rewrite this in terms of the integral from negative 4 to that certain point where we stopped, and then we changed an abruptly, which can be solved by equating this to 0, so that is negative 2. And then we'll be using the negative portion of this graph. Okay? And then we add the area that is under this negative 2 to 5. And of course, we'll be using the positive side of that graph. Okay, so hopefully it made sense now for this absolute value function. Now remember, for any discontinuity na hindi, actually not a discontinuity but an abrupt change, so especially for absolute value function, we do this parang partitioning ng ating mga areas. So we move forward to integration, so that is negative x squared over 2 minus 2x. Okay, evaluated from negative 4 to negative 2, and then plus, of course, that is x squared over 2 plus 2x, evaluated from negative 2 to 5. Okay, now for this case, we have negative 4 over 2, and then minus 2 times negative 2, and then minus 16 over 2, and then this is kind of we have negative here, and then minus 2 times negative 4, which is actually positive 8. Okay, so this is for our first term. And then for the second term, so ibahin natin yung kulay para kita niyo yung second term. So the second term would be something like 5 squared over 2 plus 2 times 5, and then minus negative 2 squared, so that is 4 over 2 plus 2 times negative 2. Okay, so we try to simplify this whole expression. So this becomes negative 2 plus 4, so that is positive 2. Okay, so hopefully ay tama yung aking dito. Positive 2. This one is negative 8 plus 8, so this becomes 0. So this one is positive 2. Okay, now adding this, we have 10 and then 25 over 2. Now this one is negative 4 plus 2, so that becomes negative 2, but this is negative, so that becomes positive 2 as well. So this is positive 2. So therefore, our answer is positive 4 plus 10, so that is 14, so that is 25 over 2 plus 14. So the answer for this expression is actually equal to 53 over 2. Okay, so that is your final area for this particular equation. So hopefully ay nakasunod kayo dun sa idea ng ating definite integral, especially when we have these odd and even functions and cases where there is an absolute value function. Just remember kung saan kayo magpuputol ng inyong limits. Okay? And the rest, kung basta continuous naman, wala tayong problema, just integrate it and then substitute the values. Basta remember, there are 3 points na I have to specify or I have to always tell you. So yung una is that just always check if the integrand, if the limits ay pasok sa domain ng inyong integrand. So if yes, then you can proceed to integration as long as there is no discontinuity. Kasi usually pag hindi siya pasok, may discontinuity doon. Pangalawa, make sure na if you evaluate the values, make sure na you apply also the properties, especially kung natural logarithm siya. Kasi there are times na hindi posibleng i-solve ng calculator, pero you can apply the properties and then you'll be able to get the result. And then siguro yung last is just to check if it's even or odd to simplify the equation. Kasi kung halimbawa same kayo ng magnitude ng upper and lower limit, magkaiba lang ng sign, then you can use the odd and even function to make your calculations a lot simpler. And then you can obtain a value of 0 kung siya ay odd, no? And then syempre kung even, multiply mo lang yung sa 2 and then you just make the lower limit equal to 0. So yun yung pwede ng mga points sa definite integral na pwede natin ma-apply in the future as well as on this lesson as well. So let's proceed siguro dun sa values of the missing limits of integration. And this is just an extension or application of your definite integral. So meron lang naman tayong tatlo dito na items. Now let's extend our application of definite integral to this kind of problem wherein we need to find the missing value of the limits of integration. So start tayo from 0 to a, and then we need to integrate 1 over 2 plus 8x squared dx, that is equal to pi over 16. Now I want to emphasize na this one is 8x squared kasi nasa handout nyo is 8x cubed. So kung 8x cubed, baka hindi tayo matapos pag-integrate dito. So make it 8x squared. So we can now start siguro yung ating solution for this, and we start by factoring out yung ating 8 in this expression. So I'll try to make this 1 over 8, and then from 0 to a, and then dx. And then for this particular case, we have that is 1/4. Kasi multiply this by 8, you get 2, and then plus x squared. This is equal to pi over 16. Now we can multiply both sides by 8 so that we can remove yung constant dito sa term ito. Now we can perform this operation because meron tayong certain value dito. So if we don't have any value here, so halimbawa wala yan, and then we need just to find the exact value. So hindi natin yun pwedeng gawin, ha. So remember that. So with this, we can say that this is 0 to a dx, and then we have 1/4 plus x squared, and then this is equal to we have pi over 2. Okay, now for this case, we know quite well that this is the inverse tangent of this x over the square root of 1/4. So this becomes 1 over 1/2, and then the inverse tangent of the ratio, so that is x over 1/2, and then we evaluate this from 0 to a, that is equal to pi over 2. Now in this case, I can rewrite this in terms of 2 inverse tangent of 2x. Okay, so that is 2x, and then from 0 to a, which is equal to pi over 2. Now you can always check by differentiating this. So if you try to differentiate, that becomes 1 over 4x squared, and then of course plus 1, and then you can do something like times 2x. So you'll be able to factor out 4x, and then you'll be left out with this expression. Now to further evaluate this, we use the idea of definite integral, and remember we're trying to assume that this one is existing, hindi siya discontinuous dun sa interval from 0 to a. So that is 2 inverse tangent of 2a, and then minus 2 inverse tangent of 0. Kasi 2 times 0 would be just 0. So this is equal to pi over 2. Now, what is the value of tangent that will make it 0? So you can just use 0 para siya yung pinakaunang value for your from the x-axis, positive x-axis. But you can always use something like a multiple. So for example, you have k pi over 2. So we can have k pi over 2. So if k is equal to 0, and then you have 1, 2, not 2, but we have 3. So this even numbers na to, so odd numbers, you can use that for the value. Pero syempre, we start with 0 kasi yun yung pinakamalapit. So with this being 0, we could perform the operation here. So you take 2 tangent inverse of 2a, that is equal to pi over 2, and then dividing both sides by 2, or multiplying both sides by 1/2. So we get inverse tangent of 2a is equal to pi over 4, and then you take the tangent of both expression. So let me just rewrite this para sakto. So tangent of pi over 4. So this leaves your 2a, and this is equal to 1. Kasi tangent ng pi over 4, we know very well na kung may pi over 4 tayo, this is this particular angle. And then yung ratio ng x and y would just be the same. I mean, sine, cosine. So therefore, a is equal to 1/2. Okay, so this is your final answer. And by the way, I would like to correct something here pala, no? Kasi our tangent is sine x over cosine x. So the value for this case would be something like k and then pi. So correction yun, ha. So k could be equal to 0, 1, 2, 3. So, pwede itong maging values pero hindi siya pi over 2. So, you can do that. So, for example, yung k mo dito is 1. So, this becomes pi. So, your solution here becomes 2 inverse tangent of 2a. That is equal to pi over 2. And then you add 2 times, of course, yung inverse tangent of pi. So, if you try to make this inverse tangent of 0 equal to pi, so pwede nating sabihin na this becomes plus 2 pi. And then if you try to add this pi over 2 and then 2 pi, you should be able to get 5 pi over 2. So if this is 5 pi over 2 and then you divide this by 2, so this becomes 5 pi over 4. And then if you take the tangent of that, so that becomes 2a, and then taking the tangent of that would just also give you a value that is equal to 1. So with this, we know very well that this also results to 1/2. That's why any multiple of k for any integer, given positive integer, so you should be able to get a value of a that is equal to 1/2. So whichever is the case, you always use naman the closest value to the x-axis kasi siya yung mas madali nating isolve, as well as mas simplified siguro yung solution if we try to do that, no? Now, for this case, I would like to correct something out in your handout, no? Yung dx, pakibura na lang yun, no? Hindi ko lang na siya nabura before, so we just have this dz over z, and then 1 plus ln squared z, and then the limit or the integral is integrated from 1 to a is equal to pi over 4. So we need to find what is this a. Okay, so we start by analyzing the integrand, and as you can see, if I try to let u equal to the natural logarithm of z, then I can take the derivative that is equal to 1 over z dz, okay, and this is the exact derivative of that u. Now from this expression, we can rewrite it in terms of u, so that is 1 to a, and then we have du, so that is dz over z, and then this ln z becomes 1 plus u squared. Okay, now we can integrate this now kasi medyo simple na siya, so we can have this inverse tangent of u integrated from 1 to a, but make sure that you substitute your value of x here, or z. So we have here the inverse tangent of ln of z. Now remember, if you have this equation, this function, no, and then ginamit mo na to, so that will mark incorrect kasi ginamit mo na yung a. Now, if you want to use this immediately, then you can use this expression para makuha mo yung upper and lower limit in this case. So, if you try to make this upper and lower limit, so you have, let's say, yung 1. So, u is equal to ln of 1, which makes this 0. So, you can use 0 to a in this case. But I will not be changing the limits of integration. I'll just return it back to the original equation kasi mas common yun natin na ginagawa before. So anyway, we have 1 to a, and this should be equal to pi over 4. Now let me just substitute the value. So we have the inverse tangent of the ln of a, and then minus the inverse tangent of the ln of 1, okay, which is equal to pi over 4. Now, remember, if you take the natural logarithm of 1, this becomes 0. And then the inverse tangent of 0 is, of course, 0. Knowing that we have a unit circle and then we try to take the value that is very close to the positive x-axis. So, yun yung una natin agad na angle na kukunin. But of course, there are multiples that we can use. Let's say yung pi nga. Actually, sabi ko na to kanina. So, but we still stick with the value that is closest to x-axis. positive x-axis. So with this, this becomes 0, and then finally, our final equation will be the tangent inverse of ln of a, and then this is equal to pi over 4. Now, to remove this inverse tangent, we take the tangent of both sides, so that is ln of a is equal to tangent of pi over 4. And we know very well the tangent of pi over 4 is equal to 1. So therefore, ln of a is equal to 1. Now, how do we perform this operation? We know very well na to remove this natural logarithm, we raise this whole expression for using the base e, or the Euler's constant. So with this, we can say that this is equal to a, and then our expression here would be e raised to 1, which is actually equal to e. Therefore, our answer is e for the upper limit of our integration. So that is simply 1 to e, and then the derivative of, the integral of dz, and then z1 plus ln squared z, that is actually equal to pi over 4. Okay, so this is your answer for this case. Hopefully, you were able to follow through these steps. So I will now solve the last item. Okay, so for C, we have the integral of from b to 1. So lower limit, hahanapin natin ito ng dx, and then e to the x plus e raised to negative x dx. And then this is equal to the inverse tangent of e minus pi over 4. So medyo complicated na yung value niya, but let's try doing this now. So if we have this expression, again, we can redefine this by multiplying the numerator and denominator by e to the x. So I'll be doing that para ma-express natin siya in terms of e to the x. So that is e to the x dx, and then this becomes e to the 2x plus e raised to 0, that is 1. Okay, so this becomes positive 1. Okay, so this is your final redefined equation for this one. Now, kung nalilito kayo, you have 1 over e to the x plus e raised to negative x. Minultiply ko lang yung e to the x both numerator denominator. So that becomes e to the x, and then e squared x plus e to the 0, which is actually equal to 1. Okay, and now I will let u equal to e to the x. We can actually use e to the let's just use e to the x. So with this, the derivative would be e to the x dx, and then why did I just let this equal to e to the x? Kasi I will try to use this just to get this e to the x dx. Kasi kung halimbawa e to the 2x yan, and then I will not be able to get this. So walang sense yung ating pag-redefine. So with this, I can write this in terms of du over u squared plus 1, which gives us the function which is the inverse tangent of u. So this becomes the inverse tangent of u, evaluated of course from b to 1. Okay, so upon substitution to our equation, that is the inverse tangent of u, which is e to the x. So ito yung b, from b to 1, this is equal to your inverse tangent of e, and then minus pi over 4. Now if you try to substitute the value, so we have the inverse tangent of e raised to 1, so that is e, minus the inverse tangent of e raised to b. Okay, and this is equal to the inverse tangent of e minus pi over 4. Okay, and we can cancel this kasi they have the same expression. And then how about this example? So with this, we know that the negative tangent inverse of e to the b is equal to negative pi over 4. So this makes sense if we take the negative of both sides. So with this, we have pi over 4. We take the tangent of pi over 4, which is equal to 1. Therefore, we have e to the b is equal to 1. And then if we try to make this or find the value of b, we just have to take the natural logarithm of both sides. So that becomes the natural logarithm of 1 for this case. And then we know very well na, diba, the natural logarithm of 1 is 0. So therefore, the ln of e raised to b is actually b, kasi pwede na ito mag-cancel out. You can move this b in front of ln of e, and then of course the natural logarithm of the Euler's constant is just 1. So this becomes b is equal to 0. Therefore, the lower limit in this case is 0. Okay, so ganun lang kasimple yung ating finding the limits of integration. And as you all know, itong procedure natin na to is that it's kind of easy when you know that you're able to find a certain fitting integrand, and then you just have to apply the f of a minus f of b. So whatever is the case, basta ganun lang, and then you'll be able to get the results that you need. But all in all, this pretty sums up our discussions for the definite integral and of course our Riemann sums. If you still have questions, meron tayong gagawing consultation, so hopefully ay ma-address natin yun. Okay?